The moon is drifting away from Earth at about 3.8 centimeters per year, which means every year our closest neighbor quietly slides one thumb width farther out into space. This happens because Earth's gravity pulls on the moon and the moon's gravity pulls on our oceans, creating tides that actually transfer rotational energy from Earth to the moon, pushing it into a higher orbit like a cosmic slingshot in slow motion. Over hundreds of millions of years, this has lengthened Earth's day and will eventually make total solar eclipses impossible, because the moon will look too small to cover the sun perfectly. So yes, one day your great many times removed grandchildren will only get slim fit eclipses and complain about it on whatever replaces TikTok. If the moon is slowly leaving, what weird scars did it leave behind from when it was much closer? For something we love to call geologically dead, the moon shakes a lot. Seismometers left by Apollo astronauts recorded over 13,000 moonquakes, some so strong they would feel like moderate earthquakes on Earth, and a few rang the moon like a bell for more than 10 minutes. Unlike our quakes, which are mostly driven by plate tectonics, many moonquakes likely come from tidal stresses, Earth's gravity flexing the moon's interior, as well as slow cooling and shrinking of its crust, which cracks like a drying mud ball in space. The result is a moon that creaks and groans in the dark, even though on the surface everything looks frozen and silent. If the moon is quietly cracking and ringing like a stone gong, what exactly is lurking under that dusty shell? The moon isn't a simple, solid rock. It has a layered interior with a crust, mantle, and small core, but the details are surprisingly odd. Seismic data and gravity measurements show a relatively small iron core compared to Earth's and regions of weirdly lumpy gravity, mascons, or mass concentrations, under big impact basins that tug spacecraft off course. These mascons are probably dense material left over from massive ancient impacts and lava floods, which means huge chunks of the moon's interior were rearranged by colossal collisions early in solar system history. New research also suggests the early lunar crust may have contained more water than we expected, hiding clues about how the moon formed and how volatile materials survived in that violent era. If the inside is that weird, what kind of chaotic event could have built this thing in the first place? The leading idea is the giant impact hypothesis. About 4.5 billion years ago, a Mars-sized object slammed into the early Earth, vaporizing rock and flinging a glowing ring of debris into orbit that eventually clumped into the moon. Lunar rocks brought back by Apollo missions have nearly identical isotopic fingerprints to Earth's mantle, which is exactly what you'd expect if the moon is made from Earth's splashed-out insides plus some of that unlucky impactor. That means every time you look at the moon, you're staring at fossilized shrapnel from the single most traumatic day in Earth's history, like a scar that decided to become a satellite. The details of that impact are still debated, including how much of the impactor survives and how the debris cooled, so in a way the moon is still withholding its full origin story, like a very dramatic side character. If the moon was forged in cosmic violence, why does its surface look like someone spent billions of years using it for target practice? Unlike Earth, the moon has no thick atmosphere, no rain, no wind, and almost no erosion, so nearly every major impact scar from the last 4 billion years is still there. There are millions of craters, including thousands over 20 kilometers wide, and vast, dark seas, the Maria, where ancient lava flooded giant impact basins and solidified into smooth plains. This surface is ground into a layer of rubble and dust called regolith, a mix of jagged rock fragments and powder produced by relentless micrometeorite sandblasting. Some regions even show mysterious swirl patterns linked to magnetic anomalies, where brighter patches twist across the surface like someone tried to airbrush the moon and got distracted. If the top layer is that shredded, what happens when that dust itself starts acting alive? Moon dust isn't just messy, it's electrically active and capable of levitating. The sun's ultraviolet light and charged particles from the solar wind can charge grains of dust, especially near the boundary between lunar night and day, known as the terminator. When the electric fields get strong enough, they can push tiny dust particles up off the surface, creating a long, thin dust storm that races along the terminator as sunrise sweeps around the moon. Apollo astronauts likely saw the effect indirectly as a strange horizon glow, as if a ghostly curtain of light was hovering just above the ground. If the dust itself can rise and move, what kind of air does a world like this even have? The moon does technically have an atmosphere, but it's so thin that scientists call it an exosphere, a wisp of atoms and particles that barely ever collide. This exosphere is constantly replenished by micrometeorite impacts and solar wind sputtering atoms right off the lunar surface, throwing sodium, potassium, and other species into space in a fragile, ever-changing cloud. Charged dust grains can join this environment, forming a kind of dusty halo that responds to sunlight, electric fields, and impacts in ways we're only just figuring out. It's less like an atmosphere and more like a faint magical aura that the moon wears, revealing itself only if you use the right instruments and a lot of patience. If the air around the moon is that strange, what about the most basic thing we look for everywhere else? Water. For a long time, scientists thought any water on the moon had to hide in permanently shadowed craters near the poles. But that story changed. Observations from NASA's SOFIA observatory detected clear signatures of water molecules in sunlit regions, including Clavius crater, with concentrations on the order of a few hundred parts per million, like a small bottle of water spread through a cubic meter of soil. Follow-up work with returned samples has found molecular water bound up in tiny mineral structures and glassy grains, sometimes in places we didn't expect water to survive. This suggests the moon's surface may host a patchwork of usable water resources, created and trapped through complex cycles of solar wind, impacts, and mineral chemistry, which is great news for future lunar explorers and slightly worse news for anyone selling premium imported moon water. If we're already finding hidden water, what other invisible tricks is the moon playing with light and shadow? The moon's gravity doesn't just raise ocean tides, it also subtly tugs on Earth's crust, and some studies suggest it may even modulate certain kinds of seismic activity on Earth. On the moon itself, low gravity and harsh sunlight create almost unnaturally dark shadows, areas so black your eyes struggle to adjust, which is exactly the kind of lighting you'd pick if you wanted to hide something unnerving in a crater. Strange transient light events, brief flashes or glows reported over the centuries, have been observed on the lunar surface, and while most likely due to small impacts or reflected sunlight, they've helped fuel the moon's long-standing reputation as a stage for cosmic weirdness. Add in those lumpy gravity mascons that subtly alter spacecraft orbits, and you get a world where even the invisible forces feel a bit playful. If gravity, light, and dust are all acting bizarre, what happens when we start leaving our own mark on this already very peculiar place? So far, more than 100 robotic missions and multiple crewed Apollo landings have turned the moon into a kind of accidental museum of human spaceflight. Up there, you'll find abandoned landers, rovers, experiment packages, flags, family photos, and yes, literal bags of astronaut waste, all preserved in the vacuum like embarrassing artifacts in the universe's least visitable storage locker. The total mass of human-made stuff on the moon is several tens of tons, from crash probes to discarded equipment, and future missions will only add more hardware, habitats, and infrastructure. One day, someone might walk through these sites and read our entire technological history in layers of metal, footprints, and forgotten tools. Assuming the moon hasn't quietly rearranged a few things, with dust storms and moonquakes, just to keep the mystery alive. If the moon already holds Earth's scars, secrets, and trash, what exactly are we walking into as we head back there for good? Thanks for watching this lunar deep dive with me. I genuinely appreciate you letting me ruin the illusion that the moon is just a pretty nightlight. If you learned something new, or now trust the moon slightly less, drop a comment with your favorite weird fact and hit like so the algorithm doesn't fling this video away at 3.8 centimeters per year. And of course, subscribe to CosmoBinge so you don't miss the next time we lovingly overthink another object in the sky.